Test. We're back. We're back. We got some time to review and study a little bit, so let's make it up. Let's get this working. So okay, cloud seems to be unresponsive. Let's use the one from my table, but I remember that doesn't work either. Oh, it's working. Awesome. Perfect. Okay, amazing. So let's start with cloud-related technologies. Let's go with cloud, which is so do we have something related to cloud? No, we don't. So let's rename this project. How can I edit? How to edit this project? Let's see. I can't edit this project. Okay, let's say this is cloud. Okay. So we got a bunch of But why this presentation? Why this is not using? Okay, let me just do it again. What? Okay, let's see some other examples. React components, Django models. What are you doing here? Let's see. Where is the code? No code. PyTorch. Hey, where is the code? Somehow this is not good. I will need to use the web interface for Cloud AI. Is it updated? Updated. Okay, this is the problem. Updated. So let's continue with AWS S3. How much time we have? Same as yesterday. Okay, it's supposed to be better now. Let's see. Yeah, seems to be better now. Let's check this out. What about cloud related stuff? No, still no. Okay, I don't care. Just okay, let's go. Let's do it. Still, why it is not using Markdown? This sucks. Let's go with AWS this time. AWS. got a lot of things to document. Okay, so we were talking about S3. We've been talking about S3, and let's see. Clearly see it now. We've been talking about S3, okay? How we can handle permissions, how we can handle access control into AWS S3. We have a variety. Variety.
Others cannot work because, for a variety of reasons,
Variety.
To tackle a broad variety of
Variety. What? Variety.
Are working in a variety of different environments.
Variety. Okay, got it. Variety. Yeah, vamos. Oh, I'm sorry. I just got up. Need to reply this thing, but I don't. I need to go to my computer. 1 second. 1 second, please. It won't take long. Just wait for me. I'll be back. I promise. What? Sorry. Okay, I'm back. Time's ticking. Okay, let's go. Quick. So we were talking about identity access management and IAM usage. So basically, AWS is talking a lot about how IAM works, how policies works. A policy can have the version, right? The version, which is going to be a date, format, input, and a bunch of statements. So each statement has an effect, action. The action can be the permission to do something. Has to be namespace colon and the name and the action you want to allow or deny. And then you have resource, which is going to be a bunch of resources that are going to be involved under that action and under that effect. You can have conditions. As part of the resource, you can have variables. Variables can apply to resources and the conditions. Conditions is optional. And in some cases you have the principal as well, meaning who is going to be the subject in under what's going to be behind this, meaning the role or the service or the external identity provider. Okay, that's pretty much it. So it's basically how AAM works. So that's a way to control the S3 buckets, whatever is related to S3, meaning buckets, directory buckets, I guess. Yes, directory buckets, lambdas, batch jobs, S3 access points, the objects, everything is related to S3. So that's a fact. Well, we also have ACLs, which is not that used anymore, not that flexible. We also have another option, which is attribute-based access control, which I don't know what it is. So let's learn. Bucket policies. Okay, where is that information? So let's go again. Yeah, I know this. Oh, we are in the first page, still not even. Okay. Resources. Principal for buckets. Can be a single user or the entire AWS account, other account. Can be public if we use wildcard. Yes, we know that. Policy action. We also have object operations, what we can do over the objects, like put object, delete object, etc. Access points, we can operate over the access point or the lambda objects also the batch operations. We got some examples, how to define the resources, variables we can use on ARNs, conditions, ACLs, attribute-based access control. So this is where we are. Okay, this is an authorization strategy that defines permissions based on attributes. Yeah, it's pretty much clear. And these are basically the tags. Wink, wink. Tags. So that tags are the attributes. So basically, tags-based access control should be the real name. You can attach tags to the AAM, entities, users or roles, and to many AWS resources. Yeah, I know I can do that. Tagging entities and resources is the first step of access-based access control. Then you design your ABAC, how to say this now? You're creating new words that I don't know how to pronounce. ABAC. ABAC.
And one at ABAC for student 4A.
ABAC.
We generally try to get more than just the ABAC.
ABAC, yeah. Tagging first step of the ABAC. Then you design ABAC policies to allow operations. It's helpful with growing rapidly environments to control access based on tags. You query tags, AWS resource tag, key name, or tag keys. In policies, you query tags. S3. Oh no, time is up. S3 existing object tag. This also works with objects. Temporary credentials with S3. What does this mean? Supports temporary credentials, yes, but what? How? The single sign-on, are you talking about Cognito? You can manually create temporary credentials with CLI API. I don't get what's the point. It's a session, a valid session anyways. Forward access sessions for S3. Support forward access sessions. What does this mean? Okay, service roles for S3. A service role is a AAM role that a service assumes to perform actions on your behalf. An AAM administrator can create, modify, delete a service role from within AAM. For more information, click this link. Service linked roles for S3. Service name and the policy. Access batch login storage lengths. Next, request of authorization. When Amazon S3 receives a request, for example, a bucket or an object operation, it first verifies the requester has the necessary permissions. Amazon S3 evaluates all the relevant access policies, user policies, and resource-based policies. Bucket policy, bucket access control list, and an object ACL in deciding whether to authorize the request or not. Does it make sense? But I guess it's not just for buckets, for objects, but for the buckets as well. Well, I mean, everything which belongs to S3, for example, lambdas, batch jobs, directory buckets, S3 tables. I mean, everything needs to have an authorization. What are you talking about? What are you repeating? What are you repeating yourself? Example, requester is an AAM principal. If the requester is an AAM principal, Amazon S3 must determine if the parent AWS account to which the principal belongs has granted the principal necessary permissions to perform the operations. Yeah, it has to verify if it has permissions or not, obviously. For a bucket, say what? For a bucket operation. How Amazon S3 authorizes a request for a bucket operation? I don't know. I don't want to know. I know it's gonna be verified, so I don't need to know this yet. For an object operation, how the validation, how authorization works. I mean, it's gonna validate. It's gonna review a bunch of policies and see if everything is in place and complies. It is going to validate the session. So here we have this graphic. User request. Is it a user or a role? What a role? What is it? If none of them, authority, bucket owner. Is it the owner? Yes. Explicitly denied. Access denied. No, it's not the owner. Well, what? No, it's not denied, even though it is the owner. Object owner. So it's authorized or not authorized for both of them. User context or other persons, other entities. So anyways, we validate here the principal, the subject, and then the permissions it has, and then the effect, allow or deny. Required permissions for Amazon S3 API operations. Okay, what do you mean? So general purpose buckets. Directory buckets have specific policy actions. They have different actions. It is actually under a different namespace. To perform S3 API operation, you must have the right permission. This page maps S3 API operations to the required permissions. when you compose policies, you must specify the resource. So we are talking about AAM again. Bucket operations and permissions. Bucket operations are S3 API operations. Yes, API is gonna be underneath, I know. You must specify S3 policy actions for bucket operations and bucket policies or AAM identity-based policies. The resource has to be a valid Amazon resource name. Yes, why will I put a wrong or an invalid ARN, something that doesn't exist or I don't have access to? So what are going to be the API operations for create bucket? It's going to be the namespace create bucket. Are you kidding me? Object operations and permissions. Oh, the multi-part upload is a permission that needs to be given to the subject if he, she or it want to upload multi-part. I mean, well, if it want to upload a big file in chunks or batches of chunks. Access point operations and permissions. Access point, object, lambda, access points, operations, and permissions. Yes, and we have more. Batch job operations and permissions. So the job doesn't have its own namespace. It is S3 describe job, get job tagging, put job tagging, update job priority. Storage length as well has its own, it doesn't have its own namespace. Okay. S3 access grants, grant operation and permissions. Access grants, okay. Policies and permissions. Again. Just, okay. Okay. Actions, effect, principle, conditions. I already took notes of everything. All of this, it's in my, even I have to repeat it myself here and here. And you want me to repeat me myself more and more. So bucket policies for Amazon S3. It is a resource-based policy that you can use to grant access permissions to your Amazon S3 bucket and the objects in it. Nothing else. So how to add a bucket policy? Controlling VPC access. So where is that? So where is this thing? Adding a bucket. Bucket policies. Controlling VPC endpoints with bucket policies. This is interesting. How you can control a network related thing with policies. This is interesting. As part of the conditions. Okay, this is another thing. As part of AAM conditions, you can query VPC source VPC. That's interesting to know. If the request is coming not from a particular AWS account or user, or nothing related with a particular tag or attribute of the bucket, but instead it's coming from a VPC that has this particular ID, then deny or allow. That's great. Restricting access to specific VPC. Yeah, you can do the same, but the opposite. Bucket policy examples. Require encryption. So you can allow to put objects. What? This example is interesting. You are denying the put object if server-side encryption is true. It shouldn't be the opposite. If server-side encryption KMS is, you are saying null. The condition is null. If this property is true, meaning it's really a null, then you deny encryption. You can also do for KMS encryptions. Can't ICLs. String equal public read. String equals. Restrict with object. That's case that users can add. By far, I am the best, bros. I am the best because I'm from Bolivia. Yeah. Managing object access control by using global conditions. What are the global conditions here? ARNs. The string equals. The source account is. So the conditions have a bunch of mechanisms to create conditionals, which is really amazing. For all values, the string not equals. So really complex conditions. I think that's the key. That's the hard part to learn about AIM policies. The conditions. The rest is easy to know. Effect, principle, actions, resources. Pretty much simple to understand. Conditions are the key. Managing access based on HTTP or HTTPS requests. Booleans. You have null, you have a string equals, you have booleans. You ask if the URL is using secure transport as false, then you deny. But how you verify that? The traffic. The origin traffic that is asking for this bucket list, not using TLS, then deny it. Amazing. You can check about prefixes as well, delimiters, string likes. For logs, what about logs? For a logs example, if load balancer needs to store logs in S3, the principal service is going to be log delivery. Managing access to an Amazon CloudFront OAI. What is that? CloudFront Origin Access Identity. So that's another principle to assign, meaning that one particular service, which is the CloudFront, origin access will have permissions to get objects from a particular bucket. Storage lengths. So we have various examples. This is great. I don't need to memorize here. I'm just reading about concepts. I will put this in practice once I'm doing laboratories. Oh, condition key. Oh, what? Wait. Condition key examples. Wow, it's another big one. You can use access policy language to specify conditions when you grant permissions. You can use the optional condition element, condition block, or whatever you want to call it, but you can use it. Amazon S3 condition keys for object operations. Example number 1. Granting S3 put object permission requiring that objects be stored using server-side encryption. I saw this before. I already took notes. But this time, this is specifying the algorithm. What algorithm is going to be used? Principles. We have deny your user permission to upload object if copy source is not this prefix, this particular prefix. Okay, the copy is going to be denied if the source is not that particular prefix. Pretty much a granular permission, this designation. Giving permission access to a specific version ID of a particular object. Interesting. So we have cool examples here. Now we are into identity-based policies, and we are done here. Bucket policies, identity-based policies. Bucket policies. Identity-based policies. This is nice. So let's go with the other thing. Let's do a little bit of Docker. Docker documentation. So I need to just to give it a look and see if everything's okay. Can I see all my chats? Because I remember I asked. No, I have anything. I don't have anything about that. I just need to make sure I got everything in place in my mind. Thinking. Okay, let's go. Build a content of all Docker concepts. Okay, everything about Docker. So what we can see here is guides, manuals. Let's see the manual. We've got a bunch of things here. When talking about Docker, we discuss the engine, the build, Docker Compose. Engine is going to be basically the engine itself, the images, storage networking, containers, CLI, the daemon, resources, logs and monitoring, metrics, security, okay, swarm mode. Do we have Docker Compose in here? No, it's not. So Docker, and what about Docker build? How to build, builders, build checks, exporters. Oh, interesting. Docker Compose, gonna be quick. Test containers for desktop. So how to use Docker in desktop? Not in server, by the way. We can build in cloud. Interesting. Docker Hub, how to use it. I mean, how to authenticate, how to pull images, that's it. Scout, Docker Scout, that's the new one. Docker extensions, Docker projects. What is Docker extensions? What are the marketplace extensions we have right now? What are the most popular plugins? But where is it? There says nothing. Administration, billing, 3D secure authentication, view, billing history. I don't care. Let's go with Docker Engine. Let's quickly take notes on here. Has to be fast. I don't feel well. I think I have cold. And blah 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 blah. Docker. So what does this have at high level? It's the Docker build, images, registries, it has networking, we have storage, the daemon, Docker daemon, we've got logs and metrics. What else? Logs and metrics. Okay, security, secrets, imps, that's it. Some Linux kernel capabilities, maybe. Yeah, mostly. I should expect all of that here. But let's see. Getting started with Docker. Let's see what I can. What? Where am I? Okay, this is talking about how to install, let's say, Ubuntu. Defining some versions, how to get the package, the repository for the Ubuntu package manager. Get the package, update, continue. Post installation setup. Manage Docker as non-root user. The Docker demo binds to a Unix socket, not a TCP port. By default, it's the root user that owns the Unix socket, and other users can only access it using sudo. The Docker daemon always runs as the root user. If you don't want to preface the Docker command with sudo, you can create a Unix group called Docker, maybe if you prefer, and add users to it. When the Docker daemon starts, meaning the socket is going to be recreated by the Docker restart, then other users from that group will have access to the Docker engine. Yeah, that's a security risk. That's why Kubernetes stopped using Docker. But people doesn't care. They are still using Docker. Need to check other alternatives. How to use it with systemd, etc., etc. Okay, so I really would like to continue with the menu, but there is no option to do that. So what I need to do is close this one and manually open the next one, storage. So what you can tell me about the storage, okay? All right, as part of installation, we are using own software repository. And then Docker runs as root. Yeah, that's a fact. So what about volume storage now? What about storage now? Or what about the time? What about the time? Okay, it's about to be time up. Storage, we have all files created inside a container are stored on a readable container layer that sits on top of the read-only immutable image layer. So the image is immutable. Everything written on top of that anything on top of that can be read, but there's going to be another layer. Data reading in the container layer doesn't persist when the container is destroyed. This means that it can be difficult to get the data out of the container if another process needs it. Storage mount options. So what are the other options we have then? Volume mounts are volumes. We got binding. We got TMPFS. We got named pipes. Okay. No matter which type of mount you choose, the data looks the same from within the container. It is exposed as either a directory or individual file in the containers file system. Volumes are managed by Docker daemon, okay? The data is stored in the file system on the host. In order to have access to it from the container, you need to mount it. The bind mounts. Volume, that's the thing. Bind mounts create a direct link between a host system path and a container, allowing access to files or directories stored anywhere in the host. Since they aren't isolated by Docker, both non-Docker processes on the host and container process can modify the mounted file simultaneously. That's another option. Binding. As a volume, as a binding. TMPF. TMPFS. It's stored in the memory, ensuring the data is not read into the disk. This storage is ephemeral. The data is lost when the container is stopped or restarted, or when the host is reboot. Name pipes can be used for communication between the Docker host and the container. Common use cases to run a third-party tool inside the container and connect to the Docker Engine API using a name pipe. So volumes, we got more examples here. Yes, this is great. We can create volumes logically. It's the preferred mechanism to persist data generated from within Docker containers. While bind mounts are dependent on the directory structure of the OS of the host machines, volumes are completely managed by Docker. Volumes are a good choice for following the use cases. Easier to backup. You can manage volumes with CLI or API. Volumes work on both Linux and Windows containers. Are safe, can be safely shared among multiple containers. When your container or app requires high performance input-output. Volumes are the better choice. A volume's life cycle. Mounting a volume over existing data. If a mount of non-empty volume into a directory in the container in which files or directories exist, the pre-existing files are obscured by the mount. This is similar to if you were to save files into empty on a Linux host and then mounted a USB drive into empty. The contents of empty will be obscured by the contents of the USB drive until the USB drive was unmounted. That's interesting. Name and anonymous volume. How to start a container with a volume. So we can inspect containers, inspect. We can do the same with Docker Compose. And we can create services with replicas, and all of them can use the same volume. Interesting. read only volume. By default is read write accessible. Wow, there's a lot of examples. We even have Windows. We have NFS being used as a volume here, where we specify the IP address of the addressers. SAMP as well works here. Okay, we got a lot. So we were looking into volumes. Volumes, the preference, and it is the next thing I need to verify. Okay, I need to see some examples and source code related to Docker volumes. So it's the same, we can create manage volumes, create, list, inspect, and we can use it to run containers. We can run it, we can write data in those volumes from inside the container, which makes sense. Bind mounts. Read only. So you are now talking about TMPFS. And you can specify the size and some permissions. Interesting. Custom volume driver. Interesting. Clean up. Container removal with volumes. Labels and filtering on the volumes. Health check. I didn't know it has health check. You are not actually running health check, you're just running df tool on a volume. Pretty much straightforward. Now let's continue with Django. Welcome to the Django. You can feel my me and the Django. Welcome to the Django. My 17 more. Welcome to the Django. Everything you want. So the next thing was views. Okay. Views. Ouch. Views. Create a super account. Okay, I don't really know if I need to understand about views because I'm not going Django, full Django. I'm going REST framework on Django. Django REST framework. But let's learn anyways. Let's see. All right. Okay, I need to time this out. I need to take this. I need to have my clock ticking. Users and groups, CRUD operations. We're doing what? Using the Django admin panel. What? Retrieve. What are you talking about? Django. Okay. We are supposed to be using this one, chapter 3. URL mapping, views and templates. Function-based, class-based views. So we got two options. Function-based. What is this about? Basically, custom functions that can return HTML content using the HTTP response object. And the name can be whatever, like home underscore page. Easy to learn, readable for other programmers. Disadvantage is that the code cannot be reused and made a consist as class-based views for generic use cases. Okay, then now, class-based views. Another way to define views using classes. Using principles of inheritance. Django's generic view classes are used. Where there are rather function-based views are explicitly coded. Class-based views inherit from the generic class. Template view. What? I don't think that is the class. Yeah, template view is a view, generic view, where each is expecting to have a template. And the template should be an HTML file. URL configuration. So this is, we define the urls.py, which is going to be for the application, not the root application. And we define a pattern. We use the views file. And we specify the view function. The view function. That particular endpoint or path will have its own name. So it expects the path, the function, and the name. So that's a path. That's one item of the URL patterns. Reverse? What is this? From Django URLs import reverse. So we can use regex as well in order to use one particular function from one particular URL pattern. using regex. Okay, so URL patterns can use regex for complex URL attributes. So we have to specify the root URL conf in the settings.py, obviously, even though it doesn't mention here. Here's a typical workflow when URL such this one is invoked using a web browser. Okay, it's gonna look into the root URL conf in the settings.py, and from there it's gonna iterate all the available URL patterns, implementing a simple function-based view. From Django, import HTTP. So, okay, it's doing the function base, which it returns an HTML with some variables in there to be rendered, and we return the HTTP response. Okay, that's a good hello world. I can try myself. Wow. Traffic is crazy and people is already complaining out there because we have economic crisis in Bolivia. Since we don't have the URL module reviews URL yet, create a file called book reviews url.py and add the following lines of code. Okay, I don't care. It's just using defining the URL and the view to be used for that particular view. So it's pretty much straightforward. Templates. Django's template configuration is done in templates variable present in the settings.py. This is how the default configuration looks like. Templates. Backend. We specify the template backend. There's options, context processors. So this is interesting. Okay. Let's go through each word present in the preceding snippet. Okay, there is an engine that processes all the HTML content in order to use the to replace the Python variables into the actual value. The Django templates engine. Directories. List of directories where Django searches for the templates in the given order. Okay, I suspected that. Updates. This tells the Django template engine whether it should look for templates in the installed apps defined under installed apps in settings.py. The default option for this is true. Options. This is a dictionary container containing template engine specific settings. Inside this dictionary, there is a default list of context processors, which helps the Python code to interact with templates to create and render dynamic HTML templates. We have different processors: debug, request, auth, context processor, messages. Interesting. We are not going to specify this. URL patterns, yes. Templates. We got here the backend. What is gonna be the backend engine? We got theirs. We got up theirs. And we got options. which are context processors. Okay, think that's it. So using templates to display a greeting message. So we define where the directories are gonna be. We create a sample HTML file and we render this using function-based views. We say render this, Django shortcuts. We got Django utils, Django DB, Django shortcuts now, and we call the function render, where we send the HTML file we want to render. This file doesn't have any variables, it's gonna be straightforward. Now we are talking about the Django template language, how to use variables, how to use loops, how to use tags, how to use comments, how to do filtering. So we have a more complex scenario here where we have to list books. We do everything here. We got all the books objects from database. We iterate one by one. We got all the reviews of each book. We generate rating average. We create a custom object array based on that, and then we render. We send that out into the books list HTML, which is expecting an object of things to be rendered. Inside the HTML, we should have a loop. We should be expecting to receive an array, an iterate array. So where is that? I don't see it. You can find the complete code here. Click this link. I'm reading the book. Yeah, that's supposed to happen. An iteration should be present in there. So we can use inheritance in templates. We can extend a main one, and we can use whatever we want in our template using extend and block. Block content and block. Block content and block is that's how we define the base. But what's the name? So just an HTML name. Okay, we're still on templates. Inheritance, that's what we were looking. Inheritance on templates. Okay, I would really like to see something, or maybe not yet. Yeah, not yet, because I already have a bunch of things to do with Django models. So let's take a look on reactjs now. This is becoming really heavy. Really heavy. The reactjs documentation. Let's set the time. Okay, let's go. Learn React. So what about React? React need to really catch up. Don't define a component inside another component. The export defaults makes the function available on different files. Use state, some generic information about components, what we have so far. So that was part of the describing the UI, I guess. In your first component. Yeah, I remember this. Pitfalls, using a component, some challenges, importing, exporting your components. That's where I left this. The magic of components lies in their reusability. You can create components that are composed of other components. But as you nest more and more components, it often makes sense to start splitting them into different files. This lets you keep your files easy to scan and reuse components in more places. Yeah, in more places. That's what we're looking for. So here is the root component file. Your first component, you made a profile component and a gallery component that renders it. So we have a profile, non-exportable, because it's going to be part of the main file, which is called app.js. Function profile returns the HTML. Export default function gallery. Export default function gallery. What's the turns? What does it return? It returns some HTML, and inside we have the previous component. Show more. Okay, show more. There's nothing else to show. Okay, that's how the profile is being used inside the gallery component. Exporting and importing. Okay, now we have two files, app.js, gallery.js. Gallery.js have the export default function gallery, which is calling inside the profile component, which is defined here above in the file. And the app.js library is calling the gallery.js. And it's doing export default function app, and it's returning the gallery component. So pretty much straightforward how to import and export components. Yeah, now this is making both of them, profile and gallery, available from outside. Recap. Now we have three files, profile.js, gallery.js. It wants me to move this function outside. I don't want to code app. So this is for kids, describing UI. Writing markup with JSX. The web has been built on HTML and CSS and JavaScript for many years. Yes, web developers kept content in HTML, design in CSS, and logic in JavaScript, often in separated files, obviously. Content was marked up inside HTML, while the page logic lived separately in JavaScript. Okay? But as the web became more interactive, logic increasingly determined content. JavaScript was in charge of the HTML. So the content being dynamically generated by JavaScript. This is why React, rendering and logic and markup live together in the same place. Components. Yeah, pretty basic. I got a pretty basic concept. Dynamic content based on variables, Boolean, conditions, events. So based on different things, we can generate a specific HTML content. Okay, how to convert HTML to JSX. So what does it mean? What JSX stands for? Didn't pay attention to that. JavaScript XML. JSX, used primarily with React library, stands for JavaScript XML. How to convert? Just take that big HTML file and split it in components. You can do this. You're just supposed to have one single root tag and put everything inside. You need to make sure to close all the tags, to explicitly close self-closing tags like img must become done. Okay. Camel case all, well, most of the things. Camel case. Use a JSX converter. Where does that exist? You just need to put everything inside a function. That's it. That's the JSX. HTML to JSX conversion. Okay, we got some challenges. Curly braces. What does this mean? Passing strings with quotes. So we have a component here. Avatar component. Class name, source, alt name, and what? Here are being passed as strings. Okay, now we have components with variables now, like a template system. So we use curly braces to define where the variable is going to be used. That's straightforward. In Python template, it's going to be double curly braces in order to use a variable, and in order to do some logics, filterings and operations, string conversions and things like that. Using curly braces, a window into the JavaScript world. Format day, today. Format day, return the date, time format in English, weekday long, and format date. So it's getting just the name of the current date based on the date format, date object. Where to use curly braces? Well, in the templates, using double curlies, CSS and other objects in JSX. Oh, interesting. So if I want to define CSS inline, I have to use double curly braces. More fun with JavaScript objects and curly braces. Thank you. Okay, so the style, but we usually don't use CSS here like this way. CSS inline. We usually have the CSS in a different file, and we can just call the class names. That's it. I will not prefer to use CSS inline. So passing properties to a component. I know we can do that now. We return something. What? Wait, we have the false. Okay, I need to check this later. Still, we're doing progress. Components. Curly braces. Oh, template. JSX. And also, this is props passing. Okay, let's go now with pytorch. PyTorch documentation. Do we really want to see components in codes? I guess yes. CSS and parameters. That's what I want to look at. We got the React component examples here. Okay. Show me some more examples using React components and CSS, and I'm using CSS with some real case scenarios using frameworks like, which one is a popular one? Tailwind, or others. Also show me component examples, passing arguments and variables, and then there those in JSX. Use TypeScript for everything. Go. Let's go. Uh-oh. Not feeling well. Oh, that's the advanced React examples. So it's creating a TypeScript. We got a bunch of interfaces. Oh, you are flying, Cloud AI. Relax, brother. Advanced card using Tailwind. Stop blinking. Come on, stop blinking. So you define handlers, events. Now, how are you using CSS? Those examples are really ugly. You're creating stars with SVG? Why you are doing this more complex than it is, bro? So you are building a e-commerce components with Tailwind CSS. So I don't know how other persons become full stack developers, where you have to learn everything. I mean, I'm trying to learn this everything by myself, even though I already have some base experience doing full stack development. But I want to become a truly full stack developer and be actually an expert in all of those frameworks, tools, and languages out there. I use those frameworks, but just partially. I read code more than I mostly read code and modified, fixed, updated, but didn't create that much code by myself. So it seems like being a full stack developer is really a complex thing to do. Either you spend years and years working in the industry, or you can just get yourself thrown into the pool in the hard way, which is reading. Anyways, reading. I'm reading right now. I'm still reading code, but now I'm also reading the concepts, which I didn't used to do before, and I don't think it's worth it anymore because we have AI reading code. Most people don't need to write code anymore, but I don't know. I have the feeling that we still need to write this code somehow, because AI can't handle complex project scenarios. Can do really good proof of concepts, but it can't maintain yet complex scenarios. So Still, there is a room for full stack developers that can write code by themselves instead of generating code from AI. Even though I'm having AI to generate code for myself in order to learn, but I can easily spot and detect wrong or anomalies or things that doesn't make sense because I already know the concepts. I already read the theory. So I can identify whatever is wrong and I can propose something better. And also including my experience as a cloud engineer. Now, and after reading a lot of code, so everything counts. Either reading code from others, writing your own code, reading documentation, writing everything in paper, everything adds up. Everything counts. You just need to have fun. Let's build a funny application, something that can be more interesting to spend time. Now let's go with pytorch. PyTorch, Ethereum, pen test. That pen testing thing, not that convinced with Port Swigger. So what about PyTorch? We've been talking about the workflow on how to train models, how tensors work, what are the properties, how datasets and data loaders work, how to load data, how we can create custom dataset classes. Pretty basic understanding. Now let's go with PyTorch. Yeah, PyTorch documentation. Let's go. Ecosystem, edge, tutorials, where learn the basics. And we were at datasets and data loaders. So we saw how to load training data and test data with datasets. We load the data, we preload the data, and we can iterate with matploy if we want. We can create a custom dataset class for own specific files. So what does this require? Oh no, I'm not feeling well. Okay, so the custom requires it needs to have the image labels. Labels that can come in CSV format, and directory of objects or assets, and we have to define the transformer. And what's this target transform? Target transform. So that's required for a custom dataset. We can iterate with the data loader if we want. We can inspect object by object if needed. Are we running on time? Okay, let's have fun. Next. Transforms. So what are transforms? Tensors, datasets, and data loaders. I need to see some examples on those. Let's ask Cloud AI to do that. So for that, we're gonna go into AI, ML. So we got some examples already here. Okay, give me more Python examples and data samples on how to use tensors, datasets, data loaders, and what? Transformers. Go, 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 go. Transforms. What is this? Data does not always come in its final process form. That is required for training machine learning algorithms. So we use transforms to perform some manipulations of the data and make it suitable for training. All torch vision dataset have two parameters, transform and target transforms. One is for the features and the other is for the labels. Okay. We have some PIL image format files, and we have the labels that are integers. For training, we need these normalized tensors, and the labels as one hot encoded tensors. So both of them, the labels and the training assets have to be tensors at the end. Tensors that can be processed by the GPU device. To make these transformations, we need to use toTensor and lambda functions. But this is specifically for torch vision, right? Transform toTensor, that's the object we need to specify. And lambda, what's that for? Target transform lambda. We are using a lambda function where we iterate, we make zeros, a bunch of zeros, and we define the float as the data type, and we are doing a scatter. What's this scatter? That's a pretty small one. So toTensor, what's this? This one converts PIL image or NumPy and the arrays into float tensor and scales the image pixel intensity values in the range of 0.0 and 1.0. Lambda transforms. Lambda transforms apply any user-defined lambda function. Here, we define a function to turn the integer into a one-hot encoded tensor. It first creates a zero tensor of size 10, the number of labels in our dataset, and calls scatter, which assigns a value 1 on the index as given by the label y. So that's it. Okay. Let's go with it. Transforms. Make the data easy to use, compatible actually, compatible by for training by using transforms. And both of them, the assets, which in this case is images, PIL format, and labels. It can be integers and go to floats. And these are both and being tensors. float tensor. That was an interesting thing. Build a neural network. Okay, I will go into this next because it's timing. I need to go out. But I want to see the examples. Oh no, this failed. Let's check this one. Tensor examples. So as part of the PyTorch, we've been doing PyTorch. Oh, no, we have a new one. Advanced tensor operations. Broadcasting in PyTorch, different tensors. Advanced indexing, Boolean indexing, fancy indexing with integer arrays. In-place operations, regular operations, adding, adds, autograd, complex operations, computing, compute gradients, attaching tensors from compute graph. Okay, custom ReLU. What was ReLU? Real-world datasets. We are still using MNIST data. Are we using Torch Vision on this one? Doesn't seem we are using Torch Vision. But we are pulling data from MNIST source. And I don't know what we are getting. Cipher 10. And we have a data structure where we have images, and still we are doing images, so meaning we are going to use Torch Vision. And it's creating the dataset from CSV file. Okay, segmentation dataset. This is really getting complex, and I like this. Text tokenizer, join transform. Transform examples in data augmentation. Okay, need to test this out. Let's go with Ethereum. Ethereum documentation. We were looking into Ethereum. Intro to Ethereum. We finished intro to Ethereum. Now we just defined some tools to use, like Viper. Instead of Solidity, we wanted to use Tenderly. Ethereum is a proof of stake, which is the basic documentation we have here. We have a video that I don't want to see. Terminology that were defined. Blockchain, EVM, nodes, accounts, transactions, blocks, smart contracts. We have the white paper. Next, Ether. What is that? That's the cryptocurrency. Yeah. What is a cryptocurrency? It's a medium of exchange secured by a blockchain-based ledger. Cryptocurrency is used for many things. DeFi lending markets, NFT marketplaces, is used as a payment earned for performing services. Ethereum allows developers to create decentralized applications, the apps. This shared pool is finite, so Ethereum needs a mechanism to determine who gets to use it. So that's the gas we need to pay. Minting Ether is the process which new Ether gets created on the Ethereum ledger. The underlying Ethereum protocol creates the new Ether, and it is not possible for a user to create Ether. Ether is minted as a reward for each block proposed at every epoch checkpoint. Burning Ether. as well as it is created, can be destroyed through a process called burning. When ether gets burned and it gets removed from circulation permanently. Denominations of ether: way, G-way, transferring ether. When it uses a smart contract, querying ether. So we have the ether scan. That's another tool interesting to just invalidate. Ether scan to publicly analyze transactions. Still, G-way calculator, Ethereum white paper, defining Ethereum and Ether. Next, into decentralized applications. Decentralized applications, the apps are operate on Ethereum, public, decentralized, deterministic, Turing complete, isolated, smart contracts, benefits, zero downtime. Oh, zero downtime. Once the smart contract is deployed on the blockchain, the network will be able to serve clients looking to interact with the contract. Malicious actors therefore cannot launch denial of service targeted towards individual apps. Privacy. You don't need to provide real-world identity to deploy or interact with the app. Decentralized app. Resistance to censorship. No single entity on the network can block users from submitting transactions, deploying the apps, or reading from the blockchain. No censorship. Amazing. Complete data integrity. Trustless computation, verifiable behavior. Smart contracts can be analyzed and guaranteed to execute in predictable ways without the need to trust a central authority. Drawbacks. Maintenance can be harder to maintain. Code is harder to modify. Performance overhead. It's huge performance overhead and scaling is really hard. Also, transactions using the proof-of-stake consensus takes time. Network congestion. Currently, the network can only process about 10 to 15 transactions per second. User experience. It may be harder to engineer user-friendly experience because the average end user might find it too difficult to set up a tool stack necessary to interact with the blockchain in a truly secure fashion. Centralization. User-friendly and developer-friendly solutions built on top of the base layer of Ethereum might end up looking like centralized services anyways. For example, such services might store keys or other sensitive information server-side. Serve a front end using a centralized server or run important business logic on a centralized server before writing to blockchain. Its centralization eliminates many, if not all, the advantages of blockchain over the traditional model. Tools for creating decentralized app. One-click app, GitHub, Etherflow, QuickNote. So it has the apps that are basically decentralized. Okay, let's put the plus ones here, which is zero downtime, privacy, no censorship, and most important things: integrity, the cons: contains congestion, bad performance. Well, not bad, but it's actually bad performance. So, okay. Web2 plus Web3 accounts, transaction blocks. I'll continue later and see if it's useful or not. Okay, this is done. And I remember we had some Python stuff, no, Ethereum stuff here using Viper. Some code examples which were Viper seems to be like Python, and a little bit of what TypeScript. I don't think so. Okay, we'll check this on my computer. Need to go out for lunch. Bye.